In this tutorial, we're going to look at the active animation event and how it can be used in conjunction with the motion transfer event to modify animations. We'll start with an imported animation of a character performing a sword swipe motion. We'll then give the character a sword prop and place an object in the way of the sword as he swipes. We'll then modify the animation by changing some of the parameters, including the character's strength. Using the active animation event allows us to apply imported animation to a character while the character is still in simulation. It works in a similar way to the active pose event in that the character uses his own muscle strength to attempt to reach the position described in the imported data. The difference between the active pose and the active animation is that the character attempts to reach the pose on every frame. Because the character is in simulation, it can interact with its environment and other events on the timeline. So let's begin with a fresh endorphin session, and we're going to load a new scene which you can find in your installation directory in the Tutorial 14 Active Animation and Motion Transfer subdirectory. We're going to load Tutorial 14 Swordplay Begin. This scene contains a single character, and this is in fact the audio motion reference character. We can confirm that if we move down to its timeline and expand that timeline by clicking on the plus sign to the left of the character name, and then hovering the mouse cursor over the character name in the timeline, we can see that it's referencing audiomotion_ref.nmc, which is the audio motion reference character file. There's a single animation event on the character's timeline and a simulation event at the beginning set to no simulation, meaning that this reference character is going to be driven by this audio motion animation. And if we click simulate, we can see the animation, which is a sword swipe motion. Now we want to transfer that sword swipe motion onto a simulation character. To do that, we need to add a simulation character to the scene, and we can do that by clicking on the Add Character icon from the main toolbar, and from the Add Character dialog, select Audio Motion 1 under Simulation Characters. You may need to navigate to the Custom Character directory in your installation directory in order that the Add Character dialog displays the Audio Motion 1 character. OK that? And now we have the reference character and the audio motion 1 character in the scene. So we now need to add a motion transfer event to transfer the motion from the reference character onto the simulation character. We'll do that by right clicking in the simulation character's timeline and creating a motion transfer event. We'll position this event so that it begins at frame 0 and then extend it so that it finishes at the same point as the animation event which has been applied to the reference character. That's about frame 220. We now need to tell this motion transfer event where to get the motion which is going to apply to our simulation character. So ensuring that the motion transfer event is selected, move over to its property view and under source character click select. And we know we want the reference character to be the source of the animation, so we can click on his name in the timeline to select him. Now let's simulate again, and this time you'll see that the motion from the reference character is being transferred directly on to the simulation character. Now this motion transfer event is working one frame behind the animation event. This means that there's a one frame offset between the animation on the reference character and that on the simulation character. As a result of this, if we move back to frame 0, you can see that the simulation character is still in a T-pose while the reference character is on the first frame of his animation. Now this may cause a few problems later on, so we want our simulation character to be in the same pose at frame 0. To do that, ensure that you have a few frames simulated and then move to frame 1 of the animation. At this point the simulation character is in the correct pose, and we're going to apply this pose to the same character at frame 0. To do this, select the simulation character's name in the timeline, and from the character menu select Save Pose. Then you can save this pose out and start pose, ensuring that the file type is .nma, which is the endorphin pose file format. And click Save. Now we can move to frame 0, again ensure that the simulation character is selected, move to the character menu and this time select Load Pose. And we can then load the pose that we just saved out onto the same character at the previous frame, frame 0. In the Load Pose dialog, ensure that Use Translation and Use Orientation is selected for both character and root, and then click OK. Now you can see that at frame 1 and at frame 0 the simulation character is in the correct pose. And I'm using the arrow key simply to step through the frames one by one. Now I want to play my animation back, so I'll go down and click the play button, but nothing happens, as you can see. The reason for that is that the loop range bar at the bottom of the timeline is set to 0 currently, so I'm going to stretch that out to finish where the animation finishes at frame 220. Now, provided I have looping enabled in my environment property view, when I click the play button, the animation will loop over the range specified by the loop range bar. And you can see that now all of the animation is being transferred from the reference character through the motion transfer event onto the simulation character. But we want to relax some of the control that this animation has on the simulation character, because we want our character to carry a sword and that sword to have an effect on the motion of the top half of this character's body. And to do this, we're going to use Active Animation. So ensure that you have the simulation character selected, and from the character menu select Character Rig Setup, and the hotkey for this is C. And this will open up the Character Rig Setup dialog. You'll have seen this before from previous tutorials. Over here on the left hand side of the dialog is the area where we associate rig nodes with mass objects, and this is where you make associations between rig nodes and mass objects for a new reference character, for example, and that again is covered in a previous tutorial. But we're interested in what's going on the right hand side of this dialog under rig node groups. Rig nodes have a set of parameters which determine the amount of control they exert over a given mass object. A rig node group is simply a group of these parameters. By default, every character has a standard motion transfer rig node group saved with it, but we can create additional groups with different values for the parameters in that group, and that's what we'll do now by clicking on the Add button, and in the Add Rig Node Group dialog we'll give this group a name of Legs Only. And that's because we want this group of rig node parameters to be set such that they'll only control the legs of our simulation character, leaving the top half of the simulation character to be controlled by Active Animation. Now you can see that the default standard motion transfer rig node group is not editable. None of these values on the right hand side of the rig node settings can be changed. But with our legs only group we can edit the type of hold that a given node has on a mass object and the value of that hold. So for the lower spine, for example, which is currently set to rotational hold, we can change the mode or type of hold to no hold, meaning that this rig node will exert no control over the mass object with which it's associated. And we now want to work through all of the other rig nodes for the top half of the body, changing them to no hold. And we'll continue to do this all the way down through right upper arm, right hand, right fingers, and then the left shoulder, upper arm, hand and fingers, until we get to right upper leg, which we leave to full hold, and then all the other rig nodes below this will control the legs and bottom half of the body. And that completes the setup of the parameter values for the legs only rig group, and we can click OK. Now back in the scene, if we select the motion transfer event and move to its property view, scroll down to the bottom, you'll see that under character rig there's a rig group of standard motion transfer currently selected. We click on that, we'll see that our new legs only rig node group is also available for selection, so pick that now. And now when we simulate, you can see that the top half of our simulation character's body simply flops around, and that's because the motion transfer event no longer has full control of the top half of the body because of the settings we put in the legs only rig node group. So now let's apply another animation to the top half of the simulation character's body. So select the simulation character in the timeline, and using the I key, select the sword swipe FBX animation file to import onto this character. In the import dialog on the right hand side, under select root node for import, make sure that hips is selected. Then on the left hand side under general, ensure that include parent transforms is also selected. However, we don't want to create any simulation events when we create this animation event, so turn off create simulation events. Then ensure that under auto motion transfer the source reference character checkbox is checked, and ensure that you're using the audio motion 1 reference character. Click OK and OK on the import dialog box to import that animation onto our simulation character. If your imported animation event doesn't start at frame 0, move it and align it so that it does, and also move it to a clear track so that it's not covering up the motion transfer event, and also make sure it ends at just about the same point as the other events. Now in this animation event's property view, set the animation start frame to 0, and now turn on active, and this is the setting which makes this animation event an active animation, so that the character will attempt to use its muscle system to match the imported animation. And in the animation event's property view we can increase the strength of those muscles to increase his ability to match the imported animation. So we'll change the strength value from 0.1 to 1. And now the same animation source is being used to drive both the top and bottom half of the character's body, but through different routes. The bottom half, his legs, are being driven by the motion transfer event, while the top half of his body is being driven by an active animation. Now we want to give our simulation character a sword to hold, so we're going to create a sword prop and place it in his hand. So from the main toolbar, click Create Fill Mass Object, move to its property view and change its radius to 0.02 and its length to 0.8. And that gives us a reasonable sword shape. And now we can use the Move and Rotate tools to place this sword in the character's hand. You can align this however you like, but to speed things along, I'm going to give you some explicit values to type into the sword's property view. So in the sword's X orientation field, enter a value of -44. In the Y orientation, a value of 46. In the Z orientation, a value of -64. Then in the X position field, type a value of 0.22. In the Y position, 0.7, and in the Z position 2.43. And this should place the sword prop approximately in the character's hand. But to keep it in his hand, we're going to use a constraint event. So let's move to the Audio Motion 1 characters timeline and right click to create a constraint event. Position this and drag it out so that it matches the other events. And in its property view, change it to a type of join bodies. Now to select the targets for this constraint, the bodies to join together, under Target Objects, click Select, move into the sword, select that as the first object, and then move into the character's hand, and using Control left click, select that too, so these will be the two bodies to join together. Now when we simulate, you can see that the sword stays in the character's hand. Now we want to place an object in front of the character to give the sword something to strike. So from the main toolbar, click Create Box Collision Object. In the new Collision Objects property view, change its height and length parameters to 0.25. Now we can position this object so that it sits in front of our character and gives him something to strike with his sword. And again, I'm going to give you some explicit values to type in the object's property view to speed things along. So for the Y position, enter a value of 1.08. And for the Z position, a value of 3.1. And if we simulate now, you can see that the sword strikes the collision object, but the character's arm goes no further than the sword will allow, so its position is dictated by the sword, whereas the reference character's arm follows through all the way as it did in the original animation. But because the top half of our simulation character's body is driven by active animation and therefore is in simulation, we can very easily modify this animation. And the first thing we're going to do is change the weight of this sword. So to make it heavier, select it and move to its property view, and we can increase its density value to 10. And this time when we simulate, you can see that our simulation character's arm is somewhat delayed by comparison to the reference character. And that's because it's heavier, and so it's taking more effort for the simulation character to lift it. But it'll become even harder if we make the character itself somewhat weaker. And to do that, we can select the sword swipe event on the timeline, move over to its strength value in the property view, and reduce that from a value of 1 to a value of 0.3. And this time when we simulate, you'll see that it's even harder for that character to lift the sword up. In fact, he slumps right over early in that animation. His head goes down because his entire upper body is now considerably weaker. And there are other ways we can modify this animation. For example, we can change the way that the sword interacts with the collision object. And we're going to do that now by changing the material properties of the collision object. But first of all, let's return the character's strength through the sword swipe animation event back to a value of 1. Now select the collision object and in its property view change the material from default to rubber. So now let's take a look at the material properties of the sword, and to do that we can select the sword in the viewport and move to its property view, and in its material field we can see that the value is set to default. So what we want to do is look at the way that the default material and the rubber material interact with each other under simulation. And to do that, we can select anywhere in the background of the viewport and move over to the Simulation Settings property view, where we can scroll down until we reach Material Pairs. And this is where we begin to define the way that different material pairs interact with each other. And we're interested in default and rubber materials, and that's currently set to bouncy, which is fine. But we have control over the way that the bouncy interaction behaves. So let's scroll up now until we reach Material Interactions, and we can see that we have a material interaction of bouncy. And these values define the way that the bouncy interaction behaves. and we're interested in the restitution value, which is effectively the bounciness of the interaction, and we want to drop that from a value of 4 to a value of 2 to make it slightly less bouncy. So now let's simulate, and this time as the sword strikes the block it bounces off, but as it comes back down you can see that it actually strikes the block twice, there and there again. To avoid this, I'm going to increase the weight of the sword, and I can do that by selecting it in the viewport and in its property view changing the density value from 10 to 15. This time when we simulate, you'll see that the sword bounces once off of the block, but on the way down misses it. And that's because the body of the character, the upper body and the arm, are behaving differently because the weight of the sword has changed. And this change in behaviour is possible because the character is being driven not only by the animation but also by the dynamics of the situation. So now let's select the collision object one more time and change its material from rubber to sponge. And this time when we simulate, we'll see that the sword passes right through the collision object and out the other side. And again, his upper body and arm behave differently and appropriately for the position of the sword. And finally, let's make the sword stick into the collision object before it passes all the way through, and to do that we're going to use a constraint. So let's go down to the Audio Motion 1 characters timeline, and you can see that currently all the event tracks are taken up, so we're going to need to create a new one. So right click on the Audio Motion 1 character's name and select Add Event Track. Now we can right click in that event track and create a constraint event. Now we want this constraint to begin at just about the point where the sword passes through the middle of the block. Let's go to just about there, which is somewhere in the region of frame 50. So if we move that constraint to begin at frame 50, and we'll make it last for about 45 frames so we can end it somewhere in the region of frame 95. Now we need to select the constraint event in the timeline, move to its property view, click the select command and select the sword as the target for this constraint. So now when we simulate, the sword will become stuck in the block, and the motion of the character's arm and upper body are dictated not only by the animation but also by the fact that the sword has become stuck in the block. So you can see that animation can be applied to characters in different ways. Using active animation allows the character not only to follow an imported animation using its internal muscle system, but also to react and interact with its changing environment.